But I am taking the class after the 10:30 p.m. also. Day before yesterday, I took up to the 11:30 in offline. LED photodiode notes I send, and now I will explain. Okay. When online today, he has given me the offer 10:30 I have to take. Okay, so now open the notes of all the. After my class, no class is there, no? Anybody announce the class? I think no. Okay, now listen. Notes, open the notes, solar diode, solar and all the photo optoelectronic device. Now I am explaining first photodiode. Okay. Okay, so photo, okay, now leave, no class is there, or no schedule is there. I think Veermani also it is not there. It is not there, no any class. Okay, listen now, photodiode is what? In notes, no photodiode and LED. I think all is there, na? Photodiode and LED is in the notes or not? No, why do you have to write the notes? There it is there. The people are not checking. They are saying, sir, it is not there. It is not there. In all the notes, it is there. No, it is there. You have to check. Order may be different. It is there. Okay. Now listen. What is the photodiode? Time is not there, so that's why no more queries is there. Okay. Now listen. What is a photodiode? Pages may be not in the order. He has not said in the order. Okay, now listen. Photodiode is what? Points are there, already there. Photodiode we are using to detect the optical signal. Any optical signal, suppose it is coming, or any light it is coming. So what is the energy of the photon? To study the energy of the photon, everything. We are using or detecting the radiation or optical radiation, we are using the photodiode. So that is also written there. Okay. So photodiode is what? It is used to detect the optical signal. Okay. Second thing, first just go through the point. I am going through the point. Photodiode we always connect in the reverse bias. All the points are there. So suppose this is a photodiode. So photodiode, that is, remember this year they will ask, photodiode is connected in the reverse bias. Photodiode is connected in the reverse bias. So it is a diode when we are connecting in the reverse bias, and here I am connecting the galvanometer. That galvanometer can measure microampere current. So order of the current through the galvanometer is what? Microampere it can measure. Okay. Suppose I am saying I have not exposed any signal. No any radiation incident on the diode. No any incident radiation, then this galvanometer will show deflection or not. This galvanometer will show the deflection or not if I connect this diode in the reverse bias and no any signal incident on that. So diode will show the deflection, galvanometer will show the deflection or not. Tell fast. Galvanometer will show the deflection or not. What the circuit I made? Galvanometer, yes, it will show. Why? Because we have learned in the reverse bias a very small current order of the microampere will flow. In the reverse bias, small current flows, that is the order is a microampere. And here I have given the galvanometer order is what? Microampere. So it will show the current or not? It will show the current or not? Tell fast. Galvanometer I have given the order is a microampere. In reverse bias, first point reverse bias, a very small current flows in a what? Order of microampere. So it will show the deflection. Okay, it will show the deflection. Okay, suppose I am taking initial current is equal to what? 1 microampere. Okay, initial current is what? 1 microampere. Because that's why here I have written microampere. Now this diode is exposed in light. This diode is exposed in light. And for this, what we do, we We put this diode in a transparent window. We put this diode in the transparent window. From that, optical signal or radiation will incident on the depletion layer. We make our window so that the optical signal will incident on the depletion layer or near to the depletion layer. Okay, so this is the light. This is the light or optical signal. So they have the photon. When they have the photon, so what will happen? The diode will absorb the photon. Diode will absorb the photon. If energy of the photon is greater than energy gap, diode will absorb the photon if energy of the photon is greater than energy gap. Then what will happen? Suppose this is the valence band, this is the conduction band. I will not repeat, that's why everybody has to listen carefully. What I am saying, when the light incident, that light has photon. What will happen if the photon energy is greater than energy gap? Then valence electron will absorb that photon and they will jump to the conduction band. If the energy of photon is greater than energy gap, electron will absorb the photon and they will go to the energy gap. When the electron will go to the conduction band, when electron will go to the conduction band, one electron and hole pair created. So when the energy of photon is greater than energy gap, then the photon will get absorbed by the valence electron. That valence electron will jump to the, we have learned in the atom. When the energy of the photon is there, then after absorbing the photon, they will jump to the higher energy state. So then electron, this will absorb the electron, valence electron will absorb the photon, valence electron will absorb the photon. If the energy of photon is sufficient, then they will jump to the conduction band. When electron jump to the conduction band, one hole created in the valence band. By that way, one electron hole pair created. And so many photon will get absorbed because only one photon is not there. In a light, so many photons are there. So what will happen? So many photon will get absorbed and more electron and hole pair will create. Why we are taking at the depletion layer? Because when electron and hole created here, depletion field is what? N2P. So due to this field, when they created, immediately they will get separate out. When they created, immediately they will get separate out due to this internal field. Electron will go this side, hole will go this side, because electric field applies the force on the positive charge in the same direction, negative charge in the opposite direction. So due to the internal field, immediately they will get separate out. Otherwise, again they will recombine. So first, due to the absorption of photon, they form. Due to the internal electric field, they get separate out. Now, electron move here, holes move here. Due to that, reverse current will increase. Okay. So suppose the new reverse current become 1.2 microampere. So before exposing in the radiation or optical signal, current was 1 microampere. When we expose in the optical signal, then we got the current is what? 1.2 microampere. So we will observe in the galvanometer, we will observe the deflection, extra deflection. So when we are observing the extra deflection, then we will say photon is absorbed. Then only extra current is coming. Photon absorbed, then I can say the energy of the photon is greater than energy gap. So we got the idea about the energy of photon incident by this way. If suppose before exposing current was 1 microampere, after exposing also current is 1 microampere, then we will say what? Photon does not get absorbed, that's why no change in the current. Then we can say the energy of all the photon is lesser than the energy gap. That's why they didn't get absorbed. Everybody got or not? Okay. Okay. Now why we are using this in the reverse bias? Why we are not using in the forward bias? Because forward bias also the current will flow. Then why we are using in reverse bias? Why we are using in reverse bias? Now listen. Here suppose initial current is 1 milliampere. I am using in forward bias and I am using in forward bias. So initial current is a 1 milliampere because forward current is the order of the milliampere. So initial current is suppose 1 milliampere. Now light absorb and the extra current flows. Extra current flows is the 1 microampere. So current increase is what? 1 microampere. So 1 microampere means change in the current is suppose 1 microampere. Initial current is what? Initial current is 1 milliampere. If I'm asking percentage change, what you will get? Delta I by I into 100. That will come 0.1%. Means if we are using in the forward bias, then what we will get? 0.1% change, 0.1% change. So galvanometer will show very small deflection, even we will not identify it is showing the deflection or not. So when we are using in that forward bias, change in the current will be what? It will not, we cannot even observe, okay? But when I'm using in the reverse bias, suppose initial current is the 1 microampere, okay? Final current, I'm getting current increased by 1 microampere. So final current is 2 microampere. How much percentage change? 50%. 50% means I can see the earlier galvanometer needle was here. Now it is showing the deflection. So easily we can observe the deflection in the galvanometer. That's why we are using this in the reverse bias. In the forward bias, deflection will be very small according to the milliampere current. That's why that we cannot observe and we cannot even identify. This everybody got or not? Okay, and like a concept of the photoelectric effect, here current magnitude will increase by increasing the intensity. That same we have learned in the photoelectric effect. Intensity of current current increases by increasing the intensity of the radiation. Okay, this everybody got? So that's why same graph we are getting the VI graph. This is the V, this is the I. But here we are using in the reverse bias, same graph you got in the photoelectric effect, current and potential graph like this. Okay, there we are getting in the, here same phenomena is happening, photon is getting absorbed, current is flowing. But here what is the difference? We are using in the reverse bias. So this is the region of the forward, this is the region of the reverse. So we will make the same graph in the third quadrant. So what is the graph we will get? So this is the intensity I2, I3, I2, I1. Then what we can say? I3 greater than I2 greater than I1. Same like when the intensity increases, then the current will increase. Understood or not? Okay, one question I have discussed there. I have given the lambda incident, optical signal wavelength I given, and I'm asking which photodiode will detect that signal. So when they are giving the wavelength, first find the energy of photon by 12,400 by lambda. You got the energy of photon. Now check that in which case energy of photon is greater than energy gap. Like one example I think I have given, energy gap of D1 4 electron volt, energy gap of D2 is the 3.5 electron volt, energy gap of D3 I gave. So I will give the energy gap of all diode. Okay, now I will compare. Photon energy is greater than energy gap, then only it will absorb. So I will check which energy gap is lesser than energy of photon. Only that diode will detect the signal. Yes or no? Like energy of photon, suppose energy of photon I gave 3.1 electron volt. Diode D1 energy gap I gave 3.5 electron volt. Diode D2 energy gap I gave 4 electron volt. Diode D3 energy gap I gave what? 2.8 electron volt. Now which diode will detect this radiation? Which diode will, if I am giving wavelength, I can find the energy by using the formula 12,400 upon lambda. So this is the energy given, energy of photon. This is the energy gap given. We know that photon only will absorb whose energy is greater than energy gap. So third case energy gap is 2.8 and here energy of photon is 3.1. So energy of photon is greater than energy gap. So who will detect this signal? Which diode? D3 will detect this signal. Understood or not? Up to this okay? So solar cell or photovoltaic cell. Solar cell means, from the name it is clear, and I think and everybody know we are using at home also solar cells and solar panel are there. So what the solar cell do? Solar cell convert the solar energy into electrical energy. It converts solar energy into electrical energy. Last year this question they asked. It convert the solar energy into electrical energy. We are using the solar panel at home also. Okay. So it converts solar energy into electrical energy. Remember, listen now carefully. It's working, everything is same. It's working and everything is same as photodiode. Okay. Photodiode is absorbing the photon, it will also absorb the photon. So working and everything is same, only one difference is there. Photodiode is work in the reverse bias, but it is a cell. We are using as a cell. So we don't need cell for the cell to behave like a cell. Means we don't need cell for the cell to behave like a cell, because cell will not use cell. So in the case of solar cell, we will not do any biasing. Biasing is not required because no biasing is there. Everybody getting or not? So that's why here cell we will not get. Everything will be same as what? Photodiode. Only one thing is what? Only one difference is there. Here we will not use any biasing. So it will work in the unbiased condition. Okay. Same phenomena. No biasing is there. What cell, sir? What cell means here we are not doing any biasing, because this I am saying it is a solar cell. So it will work as a cell. It will work as a cell. Okay. Cell means it will develop the potential difference. It will develop the potential difference. Okay. So here same PN junction, light incident. When the light will incident, then same thing will happen. Photon energy here, we are not putting the condition that energy of photon has to be greater than energy gap. Why? We are talking about the solar energy. Solar energy is what? It is containing the X-rays, gamma rays, radio, UV, the visible light, all it is containing. So definitely some photon energy will be more than energy gap. In the photodiode, we are detecting the some particular wavelength. Okay. But here solar energy I am taking. So solar energy means it contains the various photons. Okay. So that's why here condition I am not putting that energy of the, it will be definitely there because we are using the solar energy. Now the same, when it will get absorbed, electron and hole pair will get created. When electron and hole created, so due to the internal field, they will go this side, they will go this side. Now what will happen? Now here biasing is not there, so charges will not flow. So what will happen? What the extra electron, they are going this side, they will start accumulating at the end. And what the holes that are going extra this side, they will start accumulating at this end. Now you can see at the ends terminal develop. This side P side positive develop, P N side negative develop. More bigger area you are taking, solar panel more bigger you are taking, more light it will absorb, more light it will absorb, more electron and hole it will create, more charge will accumulate. Okay, more light you incident, intensity you increase, so more photon incident, more charge carrier will accumulate. In these cases what will happen? EMF will produce more. Okay, so when we are increasing the plate area, diode area, okay, solar panel, you can see we are not taking the small solar panel, we are taking the big solar panels are there. Okay, and when we increase the intensity of light, more photon incident on the panel, more photon incident, more electron will what? More charge will accumulate at the end. So bigger EMF will produce. By that way we can increase the EMF produced by the solar cell. So that polarity developed, that's why it is a cell. Now suppose I connected the external circuit, external resistance I connect. So it will behave like a cell, and in the cell we know that current flows from the positive terminal to the negative terminal. Then current will flow from the P to N. Understood? So by this way we can get the EMF. So that's why it is called the photovoltaic or the solar cell. Understood? Everybody got or not? Tell fast. Time is not there. Don't take more time for the say yes or understood. Okay. Now, solar cell VI graph is what? Up to this, okay? So solar cell is working in the unbiased condition. Solar cell is working in unbiased condition. So first quadrant we allotted for the first forward biasing. This we allotted for the reverse biasing. That's why solar cell by VI graph we make in the fourth quadrant. Why? This is the unbiased condition. It is unbiased condition. So solar cell VI graph is this. Okay. This point shows what? Here on the x-axis y0, on the y-axis x0. So here I is 0, current is 0, but potential difference is there. Potential difference is there, current is 0. It means it shows the open circuit. Why? When the circuit is not open, current will not flow, but potential difference will be there. So this point shows what? Open circuit. Okay. And here this point shows what? Here potential difference is 0, potential y on the y-axis x is 0. So here potential difference is 0, but current is there. That happens in the case of short circuiting. When you connect the two terminals with the same wire, that what? Potential difference becomes 0, but current will be there. So this situation is what? Short circuiting. Understood? That is already there in the notes. Now next is the LED. LED is the light emitting diode. Okay, light emitting diode means it is emitting the light. So its working is the opposite of the photo and the solar. They are both, other two are absorbing the photon, but here it will give the light. So it will give the photon. So LED is what? It will give the photon. So what the LED do? LED convert electrical energy into light. And LED convert, it is consuming electrical energy and it convert into the Sir, one more graph you told in the solar cell. No, it is not in the solar cell, it is in the LED. Maybe she has, whose notes I have taken, she has made in the LED. Listen, that is not the graph, any extra graph I have not said. So what I'm saying here, LED is what? It consumes the electrical energy and it consumes the electrical energy and it convert into the light. Okay. Everybody know now we are using at home also LEDs are there. Earlier we were using the filament bulb. Filament bulb, if you remember, it was giving the yellow very dim light and it was consuming more power 100 watt, 200 watt was there. But LEDs we are buying now 5 watt, 7 watt, 14 watt like that. So LED are the less power they are consuming less power, they are low voltage operated, they are more durable. Okay, that's why we are using the LED now. So next thing, it is a highly doped and it is working in the forward bias. Why? We need the high current from the LEDs so that what will happen? More light will produce. That's why we are using in the forward bias. So LEDs are working in the forward bias. Okay. Why highly doped? More charge carrier will be there, so more current will flow. So it is a highly doped semiconductor or diode, and that is connected in the forward bias. Okay. Here what will happen when we are doping more and we are connecting in forward bias? So P side, who is the majority? Holes are the majority. N side, who is the majority? Electron. So due to the forward biasing, majority hole will go this side, majority electron will go this side. So what will happen before biasing? Minorities and all are in equilibrium. N side minority was hole and P side minority was electron. Okay. But when they start flowing due to the forward bias, minority hole will increase in the N side and minority electron will increase in the P side. So due to that, what will happen? Concentration of the minority will increase. So they will start recombining. Earlier, they were splitting due to the photon. Now here what will happen? They will recombine. When they will recombine, so electron will come from the conduction to the valence. So higher energy level to the lower, it will emit the photon. Due to that, we are getting the light. Understood or not? More current we cannot say. More, it is consuming less power. Current is not coming from the LED. Light is coming from the LED. Shrisha, current is not coming from the LED. Light is coming from the LED by consuming less power. Okay, so here what happens now? There is a recombination. Due to the recombination, electron is releasing the energy that is coming like a photon. That is coming in the form of photon. One more point I have written there. Like silicon diode. So what the energy will emit, whose energy of the photon will be what? Because what I am saying here, recombination. So recombination means they will come from conduction band to the valence band. So difference of energy they will emit. So here energy of the photon will be either equal to or less than energy gap. Here energy of photon will be either equal to or less than energy gap. Okay, so photon energy emitted is less than or equal to the energy gap. Now suppose I am saying, can we use the silicon diode in the home LED? What we are using LED at home, can we use the silicon diode? So silicon diode energy gap is 1.1. Silicon diode energy gap is 1.1 electron volt. And which light we are able to see? Visible light. Visible light, violet color, maximum photon energy 3.1, 12,400 upon 4,000, and red color photon has minimum energy 12,400 upon 7,000, approximately 1.85 will come. So minimum energy of the red color, and what is it? What it is? 1.85. What is the energy gap for silicon diode? 1.1. So what I said, what is the energy of the photon emitted? Energy of the photon emitted is equal to energy gap or less than energy gap. Energy gap of silicon diode is 1.1, but for the visible light, minimum energy required for the red is what? 1.85. So energy of the silicon diode, energy gap of silicon diode is lesser. That's why we cannot use the silicon diode and germanium diode in the home LED, what we are using. Understood or not? So that's why we are using the one compound, that is the gallium arsenic and phosphorus. There are three combinations we are using to get the LED, to make the LED. Understood or not? All these points are there in the notes. Everybody got? Yeah, minorities are involved. Minority concentration is increasing. That's why there is a recombination. Due to the recombination, here energy is released. Okay. Okay. So one graph I made. That is a forward biasing, that is for the LED. That is for the LED forward biasing. Why? Because it is in the forward biasing, that's why I am making in the first quadrant. So suppose I am saying this graph is plotted for the green, red and blue color. And I mark suppose 1, 2 and 3. So which graph color represent for the green, which is for the red, which is for the blue. So if you see, remember, I said the knee voltage. Knee voltage is the minimum forward potential after which current will start changing significantly. So whose knee potential is more? Third one. Third one knee potential is more. Third one knee potential more. It means barrier more, because knee potential is equal to the barrier. Okay. So whose knee potential more? Third one knee potential more. Knee more, then barrier will be more. Barrier more means we can say energy gap will be more or less conducting. Energy gap will be more. It means whose energy gap more? They will give more energy photon. So they will give energy gap more. They will give the energy of the photon is equal to energy gap or lesser than energy gap. So knee more means barrier more. Barrier more means we can say energy gap more. Energy gap more means more energy photon I will get. So in which case I am getting the more knee I am getting 3. So maximum energy photon where I will get in the case of 3. So third will be blue, this will be green and this will be red. Understood or not? Okay, so this is over all the electric devices. Now logic gates. So first 3 point is written in the notes. Logic gate means why we are calling it gate, what is the meaning of logic here. So where we will use the logic gate. So inside the logic gate we are using the diode and the transistors. Like outside we are showing the OR gate, this representation, AND gate, this. But inside what is there? Inside is the gate. We are using the diodes and transistor. Okay. Where we are using the logic gates. So where the output possibilities are only 2 possible output are there. Then there we can use the logic gate. Like suppose I am saying any statement. I am saying any statement. then statement will be either true or statement will be false. Only two possibilities there. Either the statement is true or a statement is false. So suppose true I am giving 1, false I am giving 0. Reason is what? Computer understand only binary language, that is a 0 and 1. That's why we are using only the two output. Okay. So where the two output possibility is there, only then there we can use the logic gate. Okay, like a statement I gave, so a statement can be true or false. So only two possible outputs are there. That's why there we can use the whole is there, logic gate. Okay. Second, suppose I am saying switch, about the switch. So switch is what? Either switch is on or off. No other possibility is there. So on we are taking 1. And off we are taking 0. Switch on means switch is closed. In the current electricity we have learned, when the switch is closed, when we put the contact means switch is closed, then we are taking that is a on. On means not the open. On means switch is closed or on. Circuit is closed. Closed means circuit is closed basically. So switch on means that is a 1 and switch off means that is a 0. Suppose we are connecting the bulb. So bulb will either glow or it will not glow. So glow means 1, it will not glow, then 0. Okay. I am saying the potential difference. I gave the potential difference at one point is the 10 volt, other I gave 0 volt. So high potential, high value we will give 1, low value we will take 0. So where the two possibility is there. Okay. Everybody getting or not? So where the two possibility of output there, we can use the gate. Mainly we will deal with the 3-1, switch on 1, switch off 0, bulb glow 1, bulb not glowing 0, high potential 1, low potential 0. Understood or not? Up to this okay? Now in the class 9th and 10th, we have learned the set theory. We have learned the set theory. Okay, in the set theory, maybe name you don't know, but you have learned the intersection, union. So we are dealing mainly, we will deal with the three mathematical operation mainly. One is the OR operation. One is the OR operation. That is a later you will get. One is the OR operation. And OR operation means what? OR we represent by plus sign. OR operation means what? So OR operation we are showing by plus, means A or B, or I can say A plus B. What is the meaning of OR? So when the output will be high, what is the meaning of OR? Or if this A and B are the input. If A is high or B is high, A is high or B is high, then output will be high. High means 1. If A is high or B is high, then output will be high. If anyone means, in the case of OR, if anyone is the high, then output we will get high. Like A is 1, B 0, 1. A 0, B 1, 1. Both are 1, 1. Only one case we will get the low output when both are low, both are 0. So that is the meaning of the OR operation. What is the meaning of OR operation? Means A or B, if anyone is the high, then the output we will get high. Okay. Next operation is what? AND operation. AND operation is what? We are representing by dot. What is the meaning of AND operation? AND operation is what? The output will be high when A is high and B is high. A is high and B is high. Then we will get what? Then only output will be high. So remember, and everybody has to be very frequent, very fast in these cases. Like A and B means, or A dot B means, output we will get high only when both are high. Means both has to be 1, 1, then only we will get 1. If anyone is 0, then output we will get what? 0. So in the case of OR operation, only one case we will get 0, when both are 0. In the case of AND operation, we will get only one case. We will get the high or only one case, when both are 1. So in the AND operation, we will get the 3 possibilities 0 and 1 possibility is the only one. But in the case of OR operation, only 1 possibility is the 0, 3 operation is the 1. If any input is low, then output will be low in the case of AND operation. Yes. Okay. Then after that, NOT operation. What is a NOT operation? NOT means that we are, or invert operation. that is a bar, means not A, not A. If not A means if the input is A, then output will be not A, means input is the high, output will not high. Not high means low. If A high, input high, output low. If input low, output high. That is a what? Not gate, not operation. This everybody got? Now 9 formula you have written in the notes. That notes is there, or 9 plus 2. This is very important, and for that solving the circuit diagram problem, and everybody has to be very frequent, means no need to think, then you don't have to take the time, means A plus A bar is coming anywhere, immediately you have to write what? 1. A plus A bar is coming, then 1. A dot A bar is coming, 0. So I will write all those again. Like A plus A. So here in the case of gate, A and B are not the number, they are the condition, they are the statement. Like I am saying true plus true. True plus true, I will not say the two true. True plus true is the what? True. Okay, so A plus A, what I will write? A. Second, A plus 0. A plus 0, then directly what you will write? A. A plus 1. When in the plus operation, in the OR operation, if any input is 1, then no need to think about the other. A plus 1, no need to think about the A. Directly I can write what? 1. So anywhere I am getting the A plus 1. A value whatever is there, A bar, B bar. If one input is a 1, so OR will always give what? 1. In the case of OR, we will get 0, only the one case when both are 0. Okay. If any one is 1, no need to think about the other. Directly we will write what? 1. Okay. Then A dot A. A dot A is also what? A. True and true, then it will be true. False and false, then it will be false. Okay. Number 5, A dot 0. If anyone is 0 in the case of AND, anyone is 0 in the case of AND, then what we will get? 0. Because only one case we will get the 1 when both are 1, 1. Anyone is 0, output we will get 0 in the case of AND operation. 6th one, A dot 1. A dot 1 is 1. 1 is 1. But I don't know about A. Only one case I will get 1 when both are 1. So what? Here 1 they have given 1, but I don't know about the A. A is 1, then I will get 1. A is 0, then I will get 0. So it means it depends on A. Everybody got? Okay. Then A plus A bar. A and A bar both are present. So we know that A and A bar, whatever the A bar will be opposite of that. So definitely 1 will be 1. Definitely A plus A bar. So bar is also there, its not is also there, and it is also there. So if A is 1, then A bar will be 0. If A is 0, A bar will be 1. It means it is a combination of 0 and 1. And 0 and 1 summation is what? Always 1, because if one input is the 1, then no need to think about the other in the place of plus operation. Then directly what you will get? 1. Okay. A dot A bar. A dot A bar, both are present, it means 1 and 0 both are present. If A is 1, A bar will be 0. If A is 0, then A bar will be 1. Means 0 and 1 dot I am getting. 0 and 1 dot I am getting. So in the case of dot, we will get 1, only the case when both are 1. Otherwise, always we will get what? 0. So A dot A bar, what you will get? 0. Understood or not? Then even number of bar is there. Even number of bar means bar will get cancelled out. Even number of bar, no bar. Odd number of bar, 1 bar. Okay. So bar and bar. Then what we'll do? A. Odd number of bar means A bar. Then you will write as what? A. Okay. A bar, sorry. Odd number of bar, 1 bar. Even number of bar, no bar. Then next is the De Morgan's. De Morgan's, two De Morgan law is there. Two De Morgan law is there. So when bar is coming, bar is the with the two input together. Two input together, bar is there. Like two input together bar is there and we want to split it. So what is the rule? Break the bar, change the sign. Break the bar, change the sign. Break the bar, change the sign. Okay. So then here what you will do? A bar dot B bar. When two inputs are containing together the bar, so what I said, break the bar, change the sign. So I took the break the bar, A bar and B bar, and in the between plus, so I put dot. Same rule I will apply for this also. A dot B whole bar, then again break the bar, change the sign. Then I will get what? A bar plus B bar. Okay. Reverse also you have to remember, when both are containing separate bar, but I need one bar. I need one bar. Both are containing separate bar. So join the bar, change the sign. Reverse what we will do? Change the add the bar or join the bar, change the sign. Understood? So like here, A bar dot B bar. Then reverse if I want, join the bar, change the sign. Then what I will get? A plus B whole bar. Completed? Okay. Now types of gate. OR gate. OR gate is what? Like it will follow, it will do the OR operation. OR operation means what? Summation. So means OR gate representation is what? This. It required the two input, then you will get what here? A plus B. Truth table, everybody know. Truth table you have made in the notes also. I think no need to show the truth table. Everybody know, in the truth table of the OR gate we will get zero only one case. We will get zero only one case when both are zero. If anyone is one, then we will get what? One. Okay. So OR gate, and only one gate is there, that is required only one input. That is a NOT gate. NOT gate required only one input. Other gate required the two input. OR gate, AND gate, NOR gate, NAND gate, all require two input except the NOT gate. Okay, this everybody got. And in the truth table, 3 output you will get 1, only 1 output you will get 0 when both are 0. Okay, circuit diagram, how to decide? So if I'm making the truth table for this A, B, A plus B, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. Okay. If you see the truth table, sometimes they will give the circuit diagram and they will ask which gate it represent. So first we have to focus when the bulb, like when they will give the circuit diagram, they will give the two input means two switches they will give. A and B are the two switches. Input means switches. Output means bulb is glowing or non-glowing. According to that output we will decide. Okay. So if you see this truth table, in that case output is the bulb. Bulb is glowing, then 1. Bulb is not glowing, then 0. Only one case bulb is not glowing. Which case? When both switches are 0, 0. A 0, B 0. Switch open means, switch off means 0. Switch open means 0. So it means when both switches are open, then only the bulb is not glowing. Both switches are open, then only bulb is not glowing. Otherwise bulb is glowing. Okay. Any other case also you can see, when one switch is, any one switch is closed, bulb is glowing. Any one switch is closed, bulb is glowing. Okay. So it means the current is flowing through the switch, that is flowing through the bulb. Why? When the switch is open, then both switches open, then the current is not going through the bulb. Okay. So how we can make the circuit diagram? First battery. Okay. Both are open, then bulb is not glowing. Anyone is closed, then current will flow. Anyone means OR, means you will make the parallel switches like this. A and B. If anyone is closed, bulb is glowing, so bulb we will connect here. Now you can see, they will give the circuit diagram, you have to decide by the logic which gate it represents. So you can see here, if A close, then current will go from A and the bulb will glow. If A open, B close, current will go through the bulb, current will go through the B and it will get from the bulb will glow. Both are closed, then current, half current, and then it will go from the bulb will glow. When both are open, then only circuit is open. When circuit is open, current will not get by the bulb. That's why in that case, when both switches are open, then the bulb will not glow. So that is a circuit diagram for the OR gate. This everybody all got or not? Okay. Practice that if required. If required, then at the time of chase. Otherwise, at the time of revision, I will take the more for the gate. Okay. Now, AND gate is what? AND gate means dot operation. Dot operation means two input A and B, and it will give the output is what? Dot A dot B. In that case, we know that it will give the only one case when both are 1. Otherwise, always it will give 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. Only one case we will get 1. Now, if you see the output, then in one case bulb is glowing. One case only bulb is glowing. When both switches are closed. When both switches are closed, then only bulb is glowing. It means both switches are closed, then only it is happening. It means both switches are in the series. Both switches are in the series, and the current going through the switches, that is going through the bulb. So then you can think like circuit diagram. You can compare in the given options. Now you can see if any switch is open, then circuit will be open. Circuit open, bulb will not glow. When both switches are closed, then only current will go through the bulb, and then only bulb will glow. So this is the circuit diagram of AND gate. Okay. NOT gate representation is what? A, then output what we will get? Output we will get what? Bar of that. So NOT means not A. Not A means bar A. Okay. So it means in that case circuit diagram is very simple. A and A bar. So A0, 1, 1, then 0. It means in this case bulb will glow when the switch is open. Means if the switch will not get current, then only bulb will get current. If the switch will not get current, switch close, switch on means switch on means circuit close. It is correct. Yeah. When I'm saying the switch close means circuit close. Then circuit close means switch is on mode. Okay. Okay. Now in that case, bulb not glow in OR and AND gate. Na why bulb will not glow? Nalayak. Bulb will glow, but some cases are there. In OR it will glow in the different case, in AND it will glow in the different case. What is the meaning of that bulb not glow in OR and AND gate? Arey, bulb is glowing some cases, bulb is glowing not some cases, in the OR gate also, in the NAND gate also. Kavita, what you are asking first, clear your question, then I will clear your doubt. Okay, A bar. So here when the switch will get current, then the bulb will not get current. It means we will have to connect both in the parallel. So we can see what? Now you can see when the switch is open. When switch is open means A is 0. Then current will go through the bulb. Then bulb will glow. So means when A is 0, bulb is 1. Okay. Open means 0. Close means 1. Yes. Yes, already in the beginning of the notes you can see, Trisha. In the beginning I have said all these values. Open means off means 0. Close means on means 1. That is in the beginning first logic gate. That is only point is started. When you read the notes you will get. Okay, so A open. A open means current will go through the bulb. A open means A0. Bulb will glow. Means output is 1. Okay, when A is 1. A is 1 means this switch is closed. Switch is closed. Then current will flow through the 0 path, 0 resistance path. So this bulb will get shorted. So when A is closed, then current will flow through the bulb. Current will flow through the switch. Bulb will not get the current. That is a circuit diagram of NOT gate. Understood? Now, NAND gate. This one. What I'm saying here, not A. Not A means when A is high, A is 1, B will be 0, output will be 0. When A is 0, then output will be 1. It means when the switch is closed, bulb will not glow. and when the switch is open, then bulb will go, means reverse will happen. It means switch and bulb, they should have different connection. Why? If they will have the same connection, then means if the switch is closed, then only current will bulb will glow. So if the switch is closed, then bulb will not get current. Who will get the current? Switch. It means we have to make it parallel. Okay. Now you can see the circuit diagram. When switch is closed, then current will flow through the zero resistance path. Then bulb will not get current, so bulb will not glow. When switch is open, so this circuit is open, so bulb current will go from upper circuit, means bulb will get the current. Okay. Now NAND gate, NAND and NOR means first you have to do the and then do have the NOT. Always, like sometimes input will be complicated. Input will be complicated like A bar plus B bar whole bar, one input. A plus B whole bar, other input. So first what we will do, NAND gate means not AND. So first we have to do the AND process, AND operation. After that we have to do the NOT operation. Okay. So this is basically what? Not AND. Okay. So NAND gate is what? This is the AND, two input A and B, and NAND means here 0. So this is what? A dot B whole bar. That will be the output. Now you can see here, this is the not A, not AND. Not AND means what I am getting in the AND, here I will not get that. Okay. So in the NOT gate, how you will remember, connect the directly NOT and NAND and AND. In the AND gate, we are getting the only one case when both are 1. When both are 1, then we are getting 1 in the AND gate only. But here what will happen? When both are 1, then only we will get 0. When both are 1, then only we will get 0. Otherwise, all the cases, if anyone is 0, we will get the 1. AND gate, when both are 1, then only 1. Okay. But NAND gate, when both are 1, then only 0. Reverse, not. Everybody getting or not? That's why truth table we will get like this. A, B, A dot B whole bar. 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, then only 0. Understood? And NAND gate circuit diagram. NAND gate, you can see, when both switches are getting the current, then only bulb is not getting current. When both switches are getting current, then only bulb is not getting current. Okay. But when any switch is open, then bulb is getting current. So like both switches are in the series, A and B. If it is getting current, bulb is not getting current. So bulb I will not connect here, bulb I will connect here. Now you can see, if any switch is open, then any switch is open means anyone is 0, then current will flow through the bulb, bulb will glow. Both are closed, then current will flow from these two switches, bulb will not get current. So only one case bulb will not glow, when A and B is equal to 1. Understood or not? All circuit diagram without seeing the notes, after completing the class, all circuit diagram you will make by own, by using your logic. Okay, no need to mug up. When you will make by your logic, then any new question they are saying also you will able to do. Okay. All right, next is the NOR gate. NOR gate means not OR. Not OR means first OR. OR means A and B two input. It is not OR means like this. So A plus B whole bar. So if you remember, no, who said that mug up to the truth table? Why you will mug up? You have to know the output only. Now, why you will mug up the truth table? Mugging, for the mugging ability, if they want to check mugging ability, they can check in the bio, they can check in the inorganic chemistry. Physics, they are not introduced in the need for to check the mugging ability. For the mugging ability, they already check your bio and the inorganic. Okay, physics has given for the only what? It is the only subject that will increase your mental level. So that's why IQ level. That's why this physics is in the NEET. Otherwise, what is the use of the physics? Okay, so no need to mug up more in the physics. Physics is not only mugging. Truth table, why we will mug up unnecessarily? Okay, so here NOR gate, or first we have to sing the or we are getting 0 only one case, or operation only 0 one case when both are 0. When both are 0, then OR will be 0. Otherwise, it will be 1. Now here what we will say? When both are 0, then only we will get 1. If anyone is the 1, then we will get 0. I repeat again. We have to think the reverse of the OR. OR we are getting 0 when both are 0. Then only we are getting the 0 in the case of OR. But here what will happen? We will get 1 only when both are 0. Otherwise, we will always get 0. If anyone is 1, then we will get 0. So reverse of the OR gate. A, B, A plus B bar. Anyone is both are 0, then only we will get what? 1 here. Okay. 1 0 0 0 1 0 0 1 1 1 1 0. Okay. Circuit diagram. Now you can see when the bulb will glow when the both switches are on. Both switches are on, then only bulb will glow. Okay. If any switch is off, then bulb will not get current. It means any switch means when we have to connect the parallel. Any switch is then we have both means we have to connect in series. Any means we have to connect in parallel. Any switch is closed, then what will happen? The current will go through the switch. Like A closed, current will go through the A, bulb will not get current. B closed, current will go through the B, bulb will not get current. When both are open, then only current will go through the resistance, that is a bulb. So both are open, then only the bulb will glow. That's why it is a what? NOR gate. Understood or not? Okay. More like aptitude. That's why it is called the logic gate. It is developing your logic, and we can do the question by using the logic. Okay. Okay. So that in the note it has written 2 gate, NAND gate and NOR gate. NAND gate and NOR gate. That is called the universal gate. Why it is called the universal gate? Because other gate like NOT gate, NOR gate, NOT gate, AND gate, OR gate, all we can make by using either the NAND gate or by using the NOR gate. So that's why they are called the universal gate. So every gate we can get by using only NAND gate, or every gate we can get by using the NOR gate. Okay. I will say the gate number, how many gate number required, and by using the logic also that you can remember. Okay, so first I am saying NAND gate. Okay, so NAND gate to the NOT. Any like NAND to the NOT to the NOT, only one gate is required. So NAND to the NOT, how many gate required? Only one gate required. Only one NAND gate we can get the NOT gate. Okay. Second, NAND to the, listen, when we are going to the same, like NAND to the AND 2 gate. Like that we have to remember, NAND to the AND 2 gate. Okay. Then similarly, NOR to the OR 2 gate, NOR to the OR 2 gate. So when NAND AND, then 2 gate. Okay. When we are going opposite, NAND to the OR, then 3 gate. Then we required 3 gate. Okay. Now NAND to the one universal to the other universal. NAND to the NOR, one universal to the other universal. Up to the OR, how many gate I use? 3. But now I need NOR, means for one one extra gate I required for NOT. So how many gate required? 4. One universal to other universal, 4. Now directly you can say number 2, NOR to the NOT. How many gate? 1 gate. NOR to the OR, how many gate? OR 2 gate. NOR to the AND opposite, then we require how many gate? 3 gate. Okay. And NOR to the NAND, one universal to the other universal, then how many gate? 4 gate. So So same to same, like NOR OR, NOR to OR, 2 gate, NAND to AND, 2 gate. When you are going opposite, NAND to OR, 3 gate, NOR to AND, 3 gate, okay, and one universal to other universal, 4 gate. Which gate I am using for the conversion, that number I am saying. Okay, so 2 conversion, 2, 3 conversion I am showing. NAND to NOT, okay. NAND to NOT, then we required only one. Okay, we required only one gate, one NAND gate, okay. NOT is the only gate that require only one input, but NAND gate, AND gate, OR gate, NOR gate, all the gate require 2 input. So how we can make it? So we will take one input A and we will put in a hole both. So basically we will take A, that A we will send in the both signal, that A we will send in the both signal, okay. So by 1 we got the 2 input of the NAND, okay. Then see the output. NAND means here circle is there. Now listen, first we will do the AND, then we will do the NOT. So input of the NAND is A and A. So first do the AND, A dot A, A dot A, A, A dot A, A. So AND is the A, but we need NOT, not AND. Then what you will get? A bar. A dot A. Forget about this circle. AND process you have to do. AND means multiplication. A dot A. But you have to take the NOT, so you got A bar. Now you took the input A, output you got the A bar, then you got what? NOT gate. So by using NAND, we have got the NOT. Okay. Same way, if they are saying the NOR to NOT, just NAND you will replace by NOR. After that, same answer, and you will able to get. Okay. So if I'm saying the NOR to NOT, just in the place of NAND, you will make the NOR. You will check also. You can do that by own. Okay. Number 2, NOR to OR. Same. OR. 2 gate required. 2 gate required means NOR. Okay. So this one NOR I use. A and B input. So first do the addition. A plus B. A plus B but not. So you will get what? A plus B whole bar. Okay. A plus B whole bar. Now that A plus B whole bar, I need OR. Okay, I need 2 gate, NOR to OR 2 gate. One more gate I can use. But here output I am getting A plus B, only one output. But for the NOR gate, I need the two input. So what I will do, the same input I will split. So suppose this I am taking X. So listen, when input is long, like A plus B whole bar, A bar plus B bar, then assume the sum symbol which you are not using in the question. After that, in the last, you can put the value. Okay. So like here, A plus B bar is the input. Again and again, I will not write A plus B bar, A plus B bar. So I am taking the A plus B bar as a X. Now X and X is the input. X plus X, X. But I need NOR, so that I will get X bar. X what I assume? A plus whole bar. So A plus whole bar and 1 bar is already there. So then what you got? Double bar will get cancelled. You got A plus B. I started with AB. I got A plus B. It means what? It is a OR gate. Understood or not? How I got the OR gate by using NOR gate? We have used the 2 gates. Everybody got completed? Suppose they are asking NAND to AND. NAND to AND means in the place of NOR, you will only use the NAND. Final answer you will get AND, A dot B. So no change, no need to mug up. They will give, if you know that, very good. If you don't know, by using the De Morgan's and the input concept, you can get the, like suppose they give this gate. What is this gate represent? What does this gate represent? We will start here, AB, A plus B bar. A plus B bar is the input. Okay, I assume it is X. Then I got X bar. What is X? X, I assume this. So what is the output I got? A plus B. It means this represent what? I started with A and B. I am getting the A plus B. It means this diagram shows what? OR gate. Understood or not? Okay. NAND to NOR, one universal to other universal. So NAND, how many gate required? 4. Okay. Okay. So NAND to NOR, 4 gate required. So I am starting now. 1 NAND, 2 NAND. A, B. Okay. 2 input I have started, A and B. 2 NAND gate I use. What is the output here? A, it means what? A dot A. But bar I require, so A bar. Here also what? B bar. Now send them again in the NAND gate. Then A bar, one input is a bar, one input is a B bar. Do the product. Product means what? A bar dot B bar. But it is a NAND, so do the bar. So first do the AND operation, then put the bar. Okay. Up to this, suppose you want to solve, you can see here A bar dot B bar whole bar. Separate bars, I can write what? I can combine the bar and change the sign. Okay, and one more bar is there. A bar dot B bar, I can write what? A plus B whole bar. Now, even number of bar cancel out what you got, A plus B. So you can see here, I started with AB, I am getting A plus B. I started with AB, getting A plus B. Which gate? OR gate. How I got? By using NAND gate. NAND gate to the OR gate. I said, how many gate required? 3 gate. NAND to the OR, 3 gate required. Now you can see, by using 3 gate, I got OR. But I need NOR. I need NOR, so one more gate I will connect. Suppose I am taking this is as a X. Then X, X. Then X dot X, X, but I will get here what? X bar. What is the X bar? A plus B whole bar. Now you got what? NOR gate. So by using the 4 NAND gate, we got the NOR gate. Understood or not? If I am using the NOR to NAND, only all the NAND you will replace by NOR. Understood? Okay, so just go through the notes. First, complete all these points: conversion, De Morgan's, everything. Okay, solve simple problem, whatever the material you have. Okay, solve the simple problem like from the, if you have the Gauss-Leit's material, gym material, then you can solve the what. First, you can start with the warm up. First, solve all these notes problem. Just read it. If you are able to understand, XOR and XNOR not needed. Okay, XOR and XNOR not needed, but output I have written. Output in the notes it is there. Only output directly you have to. Okay, so that output already I have given. XOR gate and 1 point also written. XOR gate will give the high 1 when the any one is both are the different. Both are the different, then only XOR gate will give 1. Okay, and when both are same, XOR gate will give 0. In the XNOR, reverse will happen. That is written in the notes, because due to the lack of time and you have the test also, that's why I'm leaving. If required, okay, you will go through the notes. If required, then you will send to the WhatsApp to me, sir, please take the class after the exam pace. That's why I will ask them that they will not give the difficult question on the gate. If it is required, then you can send them WhatsApp to me. I will schedule the half an hour, 40-minute more that class, and I will discuss the all problem, whatever you have in the notes, or maybe some extra problem I will discuss in the gate. Okay. If you are able to understand all the notes problem, or you are able to solve the problem by using first, go through these all concept properly. Okay. Due to the yesterday, otherwise easily I can complete today, but yesterday time got killed due to the chemistry and physics. Okay, so go through the notes. All problems are there. Anybody is facing the problem, you can send that problem. I will send the recorded solution. Okay, voice solution I will send. Otherwise, if you think that we are unable to solve the problems in the problem, after reading the all notes problem is mandatory first. All notes problem you will read or you will solve by own. Okay. Okay, otherwise you can send the message in the evening. Sir, take the night at around 8 or 8:39. I will take the class. Half an hour I will discuss the all problems of the notes. Okay. Take in the night. Okay, so first go through these points. Night, if required, I will ask to send Prasad to send the message. You will get the message. Okay, I will take in the night if required. Okay, so one confirmation message everybody has. You have to send in the evening. Sir, please take. We are not able to do the problems of the gate. Okay, then I will ask to schedule, and half an hour I will take in the evening. Okay, okay then. Bye bye.